I thought we'd start with some really broad questions of chemistry and physics, and I'll go ahead and show you some of the pictures that I'm bringing up here now to sort of go along with this. And I want to talk about the distant future and how all those exact same concerns with physics and biology are going to be exactly the same, just on a different scale, and there's different other concerns, but it always is going to come back down to these essential principles. And I thought we'd talk about that as well as some of the implications that go along with that.
Yeah.
Right, hey, so let me test a few people.
Yeah. Hey, right now your screen is not on.
It's not? Is it? That's fine. That's my face. Oh, I see. Right. I didn't switch over. Hold on. And what I'm showing here is an example of one of the things that happened early on in the evolution of life. Did you ever hear about the snowball Earth?
Yeah. Just, my bad, make sure. But right now it's the picture of your Skype profile on my end.
That's weird. I didn't share. Hold on. What's going on? That's smaller. Why am I having problems in my screen?
That's not what she said.
All right. How about that? You see a guy yelling?
There we go. Yep.
Chris McKay.
I can always recognize a guy yelling. I'm in the group.
So you see this picture of Chris McKay, astrobiologist?
Yep.
Astrobiologist is that field was invented by Carl Sagan. He was the first astrobiologist. One of my professors, in fact, he was the head of Michigan State's Department of Physics and Astronomy. His name is Gene Capriati, and he's now working down in Chile, I believe, with their binocular telescope. He was actually a student. He was also a doctoral student along with Carl Sagan, and he told me how after his defense, as these guys are walking out of Carl Sagan's, where he defends his thesis, where he explains why he thinks this is true. Apparently, the biologists were kind of shaking their heads, going, "Well, at least he knows his astronomy."
Yep.
Meanwhile, the astronomers were kind of shaking their heads, like, "Well, at least he knows his biology." For what it's worth, Carl Sagan is a respectable guy, but he is kind of a sales guy more than scientist. And he really did write great stuff. Anyway, so what I'm going to show you here is the snowball Earth theory. In fact, let me tell you. Let me go back a little bit, just as a side issue. Let's talk about the invention of picotechnology. You know what picotechnology is, right?
Go over it.
So microtechnology means something.
Oh, you said microtechnology. Yeah, no, yeah. Go ahead. Sorry.
Yeah, it's named for micrometer.
Yeah.
It means a millionth of a meter.
Yeah.
And then there's nanotechnology, which is a billionth of a meter. But plants actually invented picotechnology. If you can work with a single electron, that's a trillionth of a meter. That's a picometer. So plants technically invented picotechnology because they learned how to handle individual protons or individual electrons. And this little graphic, it just shows you the electron transport chain that photosynthesis uses in order to liberate oxygen and create sugar, basically.
Yep.
And then down at the bottom of this thing is a proton gradient, which is what actually does at the level of that chloroplast, that proton gradient actually creates pressure that drives all the power of these guys. And the crazy part about cyanobacteria that invented this stuff is that they darn near killed the Earth because they started using up carbon dioxide and creating oxygen. It made the atmosphere clearer, and it looks like Earth actually went through a couple phases where basically everything damn near died.
Yeah.
It's called the oxygen catastrophe, and this happens a lot when new things come along. All of a sudden, the results hard to predict.
Yeah.
Yes. All right. So I'm not sure this guy's story.
You can anticipate, but one thing about predictions, right, is it's not as sometimes you can get the target you predicted, but you can't always you can't ever effectively predict the side impacts that you are kind of unforeseen, right?
If we imagine that this was happening on some other planet,
Yeah.
We may not be able to predict this either.
Yeah.
The only reason we have a clue now is because we have this record. And by the way, I got to point out, I'm not really sure how they figured out this snowball Earth theory, because the evolution at that time was happening at such a low level that there was no fossils.
Yeah.
So I'm not really sure how they figured this out. And I wouldn't be surprised if there's more pieces of this puzzle that we'll find out later. All right, so we got a few people showing up here, right?
Oh yeah, for sure.
And if anybody is watching and knows they got buddies interested in life and biology and the future, tag.
Just a quick on the snowball Earth theory. I'm going to have to dive into that myself a bit. It's an interesting one for me from a theological perspective, because of the waters originally. There were effectively a layer of water, above the Earth as well. So that's an interesting theory. I need to broach more. So.
Well, I thought we'd talk real briefly about some of the energy considerations.
No, for sure.
And then bump that up into the larger picture that I'm aiming for. All right, so this is a really cheap version of Excel. This is something that comes up a lot in a lot of contexts. If it's up to me, I'm gonna destroy it right now. And this is another thing that Buckminster Fuller taught me. Do you know the main function of life?
For us to help improve the environment around us.
No, like what defines life? Like
what defines? What define all of our experiences.
That's our experience of life, but what actually makes the mechanism go? And I'm kind of doing the leading question thing, so let me back off. Life is often defined in terms of replication of matter. It's often defined in terms of nutrients coming in. It's often defined in terms of the building of structures. But I want to point out that the main function of life is environmental control. Because all the life we know is based on cells.
Yeah.
And cells have inputs, and they have garbage that they ditch.
Junk.
They have growths that they create, and then of course they also produce. But the main thing that I want to cover
is the replication component, right? I mean, go ahead.
There's lots of reasons why we have to replicate. Not all life forms do. Replication is often one of the defining features of life. But I want to talk about major energy considerations. In fact, let me just do a whole new page here. When we talk about any life form, we have to have, it's got the inside and the outside, right? That's kind of a giant pen. As an example of how much we're talking about, your average person, I'm going to sort of guess the numbers, but I want to say that each of us breathes somewhere in the ballpark of 170 tons a year. That's just our air.
Yeah.
That's not even talking about the food or the water. Life absolutely requires this flow, these inputs and these outputs, right?
Yeah.
And we can talk about it at the level of a cell. We can talk about it at the level of creature. We can talk about it at the level of a planet. And when we talk about levels of civilization, I want to do a little intro to Freeman Dyson's idea. You ever heard of Freeman Dyson?
I have not. That's a new name for me.
Freeman Dyson is a physicist, and he came up with this idea for levels of civilization. And basically what he said is that level one, so in fact I'm going to do it like the video game guys, right? Level one is an entire planet.
Yeah.
And by the way, we are about 7 right now.
Yeah.
And this is just an arbitrary thing. It's just his way of talking about it. Level 2 is when we capture all the energy from a single star. And level 3 is when we get all the energy from a single galaxy.
All right.
So according to Freeman Dyson's system, we are somewhere right about
Yeah.
Or again, here, right? If this is level 1, 2, and 3, we're actually up here.
Yeah, because we effectively get the replicated energy from a star essentially from the dedicated star off of the moon, right? We take the energy from the sun off of the moon, and everything. So effectively, we're at level 1. So what's the context here, as in energy matter with us here?
If we're talking about the Earth,
All right.
A lot of the energy that we take advantage of on the Earth is in the form of agriculture.
Yep.
Right. I mean, we got our sun. Oh, come on, man. There we go. And it's radiating the crap out of the Earth, and the Earth becomes. And here's I'm gonna just do a really crappy comment here. We actually have like 15% of the land area developed.
Yeah.
And I'm not sure where anybody gets this 0.7, because we don't capture all the energy, not even close. Most of the energy that lands on the planet just warms up the oceans. Now there's things that we could do. You and I have talked briefly about this idea of OTEC.
Yeah.
Where we actually pull the energy off the oceans. Right now, is this green, by the way, or is this orange?
It's orange. It's blue all over, and then orange on the squiggly.
Oh yeah, see this is brown. I'm colorblind, so forgive me for blowing that. I'm just trying to draw confidence here. 15% of the land is actually developed for agriculture, and agriculture is gathering the energy of the planet because the sun lands on the plants and it grows them, and we feed the animals and all these other things, right?
Yep.
That's 15% of the land, and that's 15% of the land, and the land is only 30% of the Earth. So we're really talking about like 4.5% of the Earth that we actually gather energy in the form of agriculture.
Yeah.
Of course, we also got our oil, right?
Yeah.
And the oil, we can say the natural gas, and as far as that goes, the nuclear, right? The nuclear materials coming out of the planet, that's gathered energy from the planet. Our civilization is mostly those things. Our civilization is not really solar powered. It's definitely fossil fuel powered.
Yeah, for sure.
And there's a word for that. We actually have a word. There's a couple words in biology we use to talk about these types of creatures. We are known as heterotrophs. You ever heard that word?
I have not.
Hetero for different.
Yeah.
A autotroph, which means self, is a creature that can create its own fancy molecules.
It's on what?
Its own fancy molecules. So autotrophs include plants. In fact, that's all it includes.
Yeah.
Animals have to eat plants. They have to take in molecules from other creatures. So that, in broad view, doesn't level 1 mean we're harnessing the core? Well, level 1 means we're harnessing all the energy from a planet. So to the degree that there's all that geothermal, yeah, absolutely, that'd be part of it. And like Iceland, they got like 80% of their energy coming from geothermal. So it's not like we're skipping out of that.